today's second video where I can explain that how to draw a 8:1 marks using 4:1 and 2:1 marks. Okay, so let's start with this question. So first of all, you know that 8:1 marks have the 8 input and how many select lines? It has the 3 select lines. Okay, now we have to make this 8:1 marks using 2:1 and 1:2 and 4:1 marks. So how many marks is required? So for 4:4, if we want to calculate that how many 4:1 marks required, so for that you need to divide 8 by 4 and it become 2. That means 2 4:1 marks were required, and as 2 by 2 is equal to 1, that is one number of 2:1 marks is required. So this is our first calculation. How should we determine that how many marks we are taking in consideration? Now just erase it. So for it will take less time if I draw this circuit previously. So I have previously draw this circuit. So here 2 4:1 marks is taken and 1 2:1 marks is taken. So there are 2 select lines, 4 input lines for these 4:1 marks, and here it is the 2 select line and 4 input line in the 4:1 marks, and 1 outputs are there, and for these 2:1 2 input lines are there and 1 select line is there. Now so we have to make the 8:1 marks. So we need to write the truth table for 8:1 marks. So what is the truth table? So S2, S1 and S0, 3 are the inputs, not input, that is select line. Depending upon that select line combination, we can select the output. So for S2, we are taking the truth table. It is the conventional truth table. All of you know how can you write the truth table. 0 0 4 0, then 2 0 2 1, and again 2 0 and 2 1. For this it become 1 0 1 0 1 combination, 0 1 0 1 combination. So completing this truth table, we should write down the output. What are the outputs? The output should be, it is for when S2 S1 and S0 both are 0, it becomes the I0, then it becomes I1, it becomes I2, it becomes I3, it becomes I4, it becomes I5, it becomes I6, and it becomes I7. So we can now consider for these 4:1, for these 4:1 8:1 marks, we are implementing 8:1 marks using 4:1 and 2:1 marks. So for these 4:1 marks, we have 2 select lines. It means we cannot implement these 3 select lines at single marks. So we need to select any 2, either S1, S2 or S0, S1. So what happened? How should we choose? So if we are taking this as 0 and this as 0, then obviously this is also 0 and 0 because they are connected in series. So these 2 are 0. When these 2 are 0, then here I naught is selected and here it is I4 is selected. Now to get y is equal to I naught, what should we do? We should again give the 0. Now for 1 and 0, 1 and 0. So what should we do? So again we should we just change the color first. So if it is 1 and 0, then this is also 1 and 0. Now what is the output? Depending upon this select line, the output is dependent. So for 1 and 0, so if this become S1 and this become S0, considering, so this is also S1 and this is also S0. For 0 and 0 combination, when we are taken 0 and 0 combination, then both are for this output, and for if it is S0 S1, then it becomes S2. So if it is 0 and 0, I0 and I4 are selected, and if S2 is also 0, then I0 is selected. So we can consider this as S0 and S1. This is S0 and S1. Like that, if S1 is 1 and S0 is 0. See, so if S1 is 1 and S0 is 0, then what happened? So for that, here I2 is selected, here I6 is selected, here also 1 S1 and is 1 and S0 is 0. For that I6 is selected. So if this become again 0, then the output become Y become I2. And if it is 1, then so 1 0 and this is 1. If S2 is 1, then I6 is selected. So depending upon that is how we can vary the select line. Depending upon that variation of the select line, the output is selected. So this is the way how can you implement the 8:1 MUX using 4:1 and 2:1. Okay. So keep watching the video. Thank you.